Imagine a place where the Earth itself is quietly plotting a monumental transformation, one that could birth an entirely new ocean. It's happening right now, not with earthquakes or volcanic eruptions grabbing headlines, but through subtle shifts deep beneath the surface. In the Horn of Africa, in a region called Afar, forces are at work that could reshape our planet as we know it. And this isn't science fiction, it's geology in action. In this desolate, sun-scorched expanse, the land might seem ancient and immovable to the casual observer, but appearances can be deceiving. Beneath your feet, the ground is undergoing changes so gradual they're imperceptible without advanced scientific tools. These changes hint at something extraordinary, the potential creation of a vast body of water where none exists today. Over centuries, or perhaps millennia, a barren desert could transform into a thriving marine ecosystem, complete with waves, tides, and aquatic life. At the heart of this phenomenon lies one of Earth's most fascinating geological quirks, a triple junction. This is where three massive tectonic plates, the Nubian plate, the Somali plate, and the Arabian plate, meet and slowly drift apart. Such junctions are incredibly rare, and the Afar Triangle is among the few places on Earth where scientists can witness this process firsthand. The Red Sea, the Gulf of Aden, and the Ethiopian rift all converge here, pulling the African continent in different directions. But how does such a dramatic change occur? Through a process known as rifting. As these tectonic plates separate, the crust between them stretches and weakens. Below the surface, heat and pressure from the Earth's mantle rise upward, softening the crust further and encouraging fractures to expand. This relentless stretching creates valleys, and eventually, if given enough time, those valleys may fill with seawater, forming a new ocean basin. Leading the charge in understanding this intricate process is Emma Watts, a geologist affiliated with the University of Southampton and Swansea University. Her team has been studying volcanic rock samples collected from rift zones spanning the Afar region. What they've uncovered paints a picture of a dynamic, almost living system beneath the Earth's surface. The mantle below isn't just warming up, it's pulsing with activity. Think of it like a faint, slow heartbeat driving molten material upward and thinning the crust bit by bit. Each pulse widens existing faults, setting the stage for even greater transformations. Here's where things get intriguing and slightly controversial. The chemical makeup of the rising magma varies depending on its direction of movement. For instance, when the molten material flows toward the Red Sea, it exhibits distinct properties compared to when it heads toward the Gulf of Aden. Does this mean certain areas within the Afar Triangle are evolving differently? Could some parts become oceans faster than others? These questions remain open, sparking debate among geologists about the timeline and specifics of this continental breakup. To truly grasp what's unfolding, let's zoom out for a moment. Continents aren't static entities. They're constantly in motion, albeit at a pace invisible to human lifetimes. This concept, known as continental drift, explains how land masses shift over millions of years. In Afar, however, this drift is happening in real time, offering us a front-row seat to Earth's ongoing evolution. The Nubian and Somali plates continue to pull away from each other, while the Arabian plate moves northward. With every millimeter of separation, the crust thins further, edging closer to the possibility of seawater flooding the Rift Valley. While we won't live long enough to see the final outcome, future generations might find themselves sailing across waters that once were arid plains. Thanks to researchers like Watts, we now have a unique window into the birth of an ocean. Their findings remind us that the continents we inhabit today looked vastly different millions of years ago, and will continue to change long after we're gone. So here's a thought-provoking question. If a new sea does emerge in Ethiopia centuries from now, What stories will historians tell about its origins? Will they marvel at the quiet, persistent forces that shaped their world? Or will they wonder why humanity took so long to fully appreciate the planet's ever-changing nature? Share your thoughts in the comments below, because this is more than just geology. It's a testament to Earth's resilience and creativity.